All right, we're recording. All right, everybody online, still good. Here we go. So, completing the square is something that's done with a problem like this. Everybody write it down. Now, what would you normally do when you see a problem like this to solve it? Factor, right? We would do an x. So we're looking for two things that multiply to get negative 20 but add to get 8. Anyone think of one?
5 and 4.
5 and 4 don't work. 10 and 2 do work. Which one would be negative? The 2. So we already know that here's how this problem really should go. Negative 20, 8, 10, 2. Then you have what? X plus 10, x minus 2. So our answers would be what and what? Negative 10, positive 2. Now I am going to show you how to complete the square instead with this problem. I would not suggest that you complete the square normally with this problem because this problem is solvable just by factoring and making it really easy, right? The reason why I'm complicating it is because I'm using a simple example to do a complex thing, and then we'll have problems that you can't solve with factoring that you have to do the complex thing with. So trying to make it easy. Okay, so let's draw a line here so that you don't get confused in your notes about what we're doing now. So what we're going to try to do is the goal is to make this a perfect square. So the first thing I'm going to do is get that 20 out of the way. So I'm going to put it on the other side. I'm also going to leave some room here. So it's going to look like that. Why is it positive 20 on the other side?
Add on both sides to cancel out.
Right, add 20 on both sides to cancel it out. So now I've got it looking like that. And then I'm actually going to draw a square and complete the square. And I'm like the only math teacher around that I know does it like this, but I like it because it's actually a square. I know you guys did this with Thorson, but I'm guessing that you did it like most math teachers teach it, which is just like a list of rules, kind of steps to go through. Anybody remember those steps by chance? This is literally something that when I went to college and they were like, remember how to complete the square? And I'm good at math. And I was like, no, sir. I definitely don't. There are a few things that leave you fast, and this is one of them, but I'm hoping that this way sticks. Okay, so we're going to try to make this a perfect square, and by perfect square, I mean that the top is going to be the same thing as the side. So I'm going to put x squared right here. And this middle number, that's these two added up, right? But I want it to be perfect. I want them to be exactly the same. So what two numbers add up to get 8x, but are both the exact same number?
4.
So I'm going to put 4x here and 4x here. Do you see how so far this is x squared plus 8x? Okay, now let's do it this way. What should I take out? Just an x here. And how about on the top? Same? And then I'm trying to get a 4x, so this has to be 4 and this has to be 4, which is perfect because I want them to be the same thing. But the question is, what am I missing right here? 16. All right, so what we want is 16. But do you see how the original thing that I wrote only had these 3 in it, not that 16? So I'm going to force it to be a perfect square by adding 16 here, but I'm going to add 16 on this side too because I want my sides to be equal. And then I'm going to rewrite the left side. So that's now x plus 4 squared because I've got x plus 4 here and x plus 4 there. And that equals what?
36.
36. Because 20 plus 16 is 36. All right, now we're going to solve it like it's a square root problem. So how do I get rid of the square?
Good morning, sophomores. If you need a
Square root. square root, so I've got x plus 4 equals plus or minus 6. And then I'm going to subtract 4 on both sides. So now I have negative 4 plus or minus 6. What's negative 4 plus 6? Negative 4 plus 6. 2. And then negative 4 minus 6? Negative 10. So my two answers are negative 10 and 2, which is what we figured out at the beginning. Okay, so this is a hard thing to do, completing the square, although you just have to actually literally complete a square. Would it help you guys? How do you want to do this? Do you want to just do more examples right now, or do you want to do, like, should I make a list of steps that you could follow in your notebook, or would you just prefer, like, do you want to just try a couple more and see if you're used to it before we do steps? Opinions online?
I vote steps.
Rylan votes steps.
I like doing examples and just working on.
Mitchell says examples. We got one for each. Anybody have an opinion online? Come on, guys, unmute, talk to me. Ayla, what'd you say? Examples? I'm sorry, Ayla, I keep talking over you. Say it one more time.
Examples.
Okay, so we're going to try some examples first, and then we can go back to steps, okay?
Can you explain how you got 2 and negative 10? I was writing and I didn't see it.
Sure. It was negative 4 plus 6 makes 2, and negative 4 minus 6 is 10, negative 10.
Got it, thanks.
Yep. Okay, so we're going to try again. X squared minus 6x plus 21 equals 0. What in the world happened there? Neat. Okay, can anybody think of, like, if we were actually going to factor this with, like, an x problem, can anybody think what would possibly multiply to get positive 21 but add to get negative 6? Multiply to get 21 but add to get negative 6? Like if we were doing an x problem? Yeah, there's nothing. So this is one we definitely have to do, completing the square. All right, somebody remind me, what's the first thing I did with that 20?
Minus 21 on both sides.
Right, so I'm going to minus 21 on both sides. I'm going to get that third term out of the way. So now I've got x squared minus 6x plus, and I'm going to leave some space and put negative 21 on the other side, because I intend on adding something there. Now I'm going to make the square. What goes in the square? Remember, we want it to be perfect. We want it to be the same on either side. What goes right here?
X squared.
X squared. And these two have to add up to negative 6x, so they need to be negative 3x, negative 3x. On the outside, this is x, this is x. I feel like I'm going a little too fast. Over here has to be negative 3 and negative 3. So what's missing? Positive 9. Negative 3 times negative 3 is positive 9. So I'm going to throw that here and over here. But if I take negative 3 times negative 3, I get positive 9. Because if I take 9 divided by negative 3, I get another negative 3.
You're like filling in the box as well as putting them.
It's just usually you take it out.
Right, and if you take it out, this one is a hard one because these two are negative, and that one has to be positive, so that means these two edges here have to be negative. Okay, so now I've got x minus 3 squared on the left side. That was the goal, right? To make a perfect square, x minus 3 and x minus 3. And on the right, I have negative what? 12. All right, what's the next step?
Square both sides. Or square root both sides.
Square root, square root. I think that you say square when you mean square root. Anybody remember how to break down 12? Right, so it's 2 square roots of 3 because I'm taking out a pair of 2's, or you think about like the square root of 4 is 2. Yep, you definitely need an I right there. And you need a plus or minus. Why did we need an I? Because it's a negative, and the plus or minus because we did a square root. And then my final answer is 3 plus or minus 2I times the square root of 3. And that first 3 just came from me adding 3 to both sides.
Do you always put I outside the square root?
Yes. You could put it after the square root, I guess, but you